Breast cancer. Most of you here will know of someone who's been affected by this horrible disease. So I don't really need to tell you that it's the most common cancer found in Australian women, with 1 in 9 diagnosed before the age of 85. And I certainly don't need to tell you that there is no cure. Only treatments, like chemotherapy, that plough through the body like a bulldozer, destroying everything in its path, including healthy tissue. But what if we could selectively destroy just the cancerous cells, so that the healthy tissue could be left alone? Well, this is where my research comes in, as I'm aiming to develop a chemotherapy drug delivery system that will only destroy cancer cells. Now, cancer dominates over our healthy cells because it grows very rapidly without constraint. It does this by growing lots of tiny little blood vessels from one pre-existing vessel. This results in a tangled web of blood vessels, much like the roots of a weed, that are very leaky, which allows particles of a certain size to be able to pass through the blood vessel wall and into the tumour tissue. Now, liposomes in my cells, which are nano-sized particles, are the perfect size to be able to do this. So imagine if we put a current chemotherapy drug inside a liposome or a micelle, which could then act as a biological vehicle, driving our chemotherapeutic to the tumour, whilst also shielding and protecting our surrounding healthy tissue from being harmed. Being the perfect size, this vehicle will have no problems penetrating through the blood vessel wall and delivering a high dose of the chemotherapy that it's carrying directly into the heart of the tumour. Now, breast cancer tumours also overexpress hormone receptors that grab hormones like estrogen from the bloodstream, which allows it to keep growing rapidly. Now, as a chemist, I'm trying to make liposomes in my cells that have a chemotherapy drug tamoxifen attached to the outside. The special thing about tamoxifen is that it mimics the hormone estrogen, which means our receptor will grab it and pull it into the tumour by mistake. Now, this is helpful as it can act as a GPS for our liposome, guiding it to our tumour, where it can then release a second dose of a different sort of chemotherapy into the tumour. Now, this double-barrel delivery system means that we can deliver a high dose of the chemotherapy directly into the breast cancer tumour, which will minimise side effects. So, with my research, the very thing that gives cancer its competitive edge can ultimately bring about its demise. Thank you.